You go. Should we start?
Yes, Guy, please. I think we can start. We can start.
Okay.
Right.
Okay. Welcome everyone, and thank you for joining. Today we'll continue with our examples. We are going also for 2 more games to play. Okay, but first off, one of them we will follow OOP approach to performance, and the other one will keep it functional because it will be your assignment to reproduce it as OOP. Now, the idea here is just to see different scenarios of programming and how we are able to perform some, for example, drawing methods or how to interact with the screen. And how to collect information using the screen. If you remember just in the beginning, just remember that we have 4 major components in any programming, which is collecting data from user using maybe some forms to enter the data, or also from the keyboard, mouse, touch screens. All of this is collecting information, collecting data from the user. Then we have the assignment and mathematics. Then we have the loops and we have the conditions. We say that everything at the end, it can be translated into one of these 4 or at least of these 4 instructions. And today we will see how to collect information from especially the mouse in our situation. I'll share my screen to start. Oh, sorry. Hugo, please make me host or give me permission to share the screen. Okay. Okay. So the first game for today, it will be last week we just quickly take a look about it. It's the tic-tac toy. Simply, it's we build in a simple way. Why? Because we are just in testing. That means we are not going to make this game. We are not going to push it in production. We have the board, and this board, inside the board we have 9 cells. Okay, and then we will play each. It's turn by turn. That means one click for the X, the other click it will be for the O, and go on. And then once we have, for example, 3 X's in line, the X will be the winner, or otherwise we have 3 O's, then the O will be the winner, or it might be a draw in general. According to that, there is no winner. It's a tie game. Now, this is the game. It's a simple game. It has some kind of visualization. We will see how to produce this game. Let's start from the logic itself. By the way, because when I'm sharing my screen, I'm unable to check the chat. So please, if anybody has a question, he just unmute and ask his question. Okay. We started last week and we explained how we create this class, the tic-tac-toe, and we show the constructor, which is, we name it the birth method. That means it's the method called when we create instance from this class. But to start with the game, first let's think about what libraries we need. First of all, we need a library or package to help us to create the windows, the window that we are showing, the board and all of this. Now, you can imagine what's the situation in the old days when you have to draw all of these components by yourself. Right now, there is ready-made packages. It's using the libraries and APIs available in the operating system to help you to generate the window and also track the events. And we will explain what is the event later. One of these, it's the tkinter, this one. So we are just import everything from tkinter. This package is helping us to create the windows buttons, all the component of any application in Windows application. Now, just for to remind you that in the beginning, it will not be installed in the environment. So we have, if you are using, just like me, the Visual Studio, we have to go here to the Python environment and go to the package PyPy, and then write the name of the package here. It's for the first time. And then we can run a pip installation for it. According to that, we will install the package into the environment and we will be able to import it like this. So I already performed this, this task previously, so I'm not going to repeat it once again. But here, for example, we have to write the T enter, and then we can find that there is a pip installation command. We can run it by clicking on it. This is how much easy the Visual Studio make the task for us.
Okay, sorry guys. Can you also show how to do this pip install from command line?
No, because I'm very I'm depending a lot on the Visual Studio, so that's why even I might make a mistake right now. But to solve this, I promise to provide you with a small video about this, how to do it, and how to manage in general the Python environment, the virtual environment of Python. Because as I mentioned in the last session, we might make a mistake that using the, let's say, the default Python environment for all the packages, and according to that, all the packages will be installed for each and every project. In this case, we are increasing the size of the project for nothing. That's why it's preferred at least to categorize the projects that we have. If the project are a game, it's different from machine learning project, it's different from other kind of project. According to that, we'll create virtual environment for each project. And we will install for this virtual environment what's needed for these, let's say, family of project only, instead of having all of them installed. Now, for managing the virtual environment and for the pip installation on the command line, I will provide you with a video, separated video. You can add it to the channel and everyone can check it later, because since I'm working on the production, so I'm focusing on, I'm using all the possibilities of Visual Studio because it's faster for me. That's why I'm depending on it very much. And by the way, I'm C# programmer in the originally, so that's why I'm very happy with the Visual Studio. Okay, but yes, I know how to do that, but maybe right now I'll make a mistake if I go there. Okay. Now, first we import the tcenter, and then we will go and import NumPy. Why? Because we have a lot of numeric operation needed to exactly determine where we are clicking. When we click on the board, we choose a specific cell from these 9 cells, and this is, it needs some kind of calculation to perform. After the importing of the libraries, we have, just a minute, we have a global variables. We start with it. First of all, it's the size of the board, and we choose 600 pixel, which is, it will be a squared board by 600 and 600. Now, the second is the symbol size. Now, what is the symbol size? It's the X or O size. Okay, what this should mean? We have to, let's say, a design in mind, or in the virtual memory that we have, we have to know that how much the square that contain the symbol itself. By the way, I'm not talking about the cell in the board. I'm talking about the square that contain the symbol. We have to know the width and height for it. So here I'm suggesting simply just to get the third of the size of board, and then also make some kind of margins for it, and then I'm splitting into 2. So at the end, I know exactly that it's almost the X, it will be almost the size of the cell, but it's a little bit less than that. According to that, it will be suitable in place. So the symbol size, I'm calculating it depending on the size of the board in general. Now, if I change the size of the board, okay, by heart, I will know that the symbol size, it will be changed and it will still suitable for the new size. Symbol thickness, it's the line thickness. That means when we draw something, we have the pin thickness or the pencil thickness, for example. So this is the symbol thickness, and we choose it as a 50 pixel because we want a bold and clear symbols. Then some kind of colors. This is RGB codes for example, the first two letters, it will be for red, and then green, and then blue. So it's kind of code to determine the color. And by the way, it's numbers, it's not letters, but it's following hexadecimal counting system. Hexadecimal, it's considering that we have a 16. It's not like decimal. We have 10 numbers from 0 to 9. No, we have 16 from 0 to F. Now, what this should mean? Okay, we start by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then the next step, it will be A, which is suitable for 11, for example, A, B, C, D, F, E, F. Okay, so it's the base of this numeric system. It's 16 digits instead of 10 digits. Okay, that's why it's named hexadecimal. That means it's from Latino language, I think, or from Greek. I think from Latino language. And this one is used for coding the colors. By the way, when we are talking about EE, that means we are talking about the value of 1515 for, and this is the code for the red. And then 40, it will be the code for the green. And then 35, it's the code for the blue. Now, mixing this, it will make kind of light mixing to create the new color that, or the color that we are looking for. So any color can be encoded into components from 3 colors, which is R, red, green, and blue. Now the same for the O, we are encoding it into by hexadecimal, and the same for the green color. Green color, it's I think it's just used for the background of the symbols of the board. Okay, so this is the global variable. This is something will not be changed. Okay, it's one time we define it and we are using it inside the game. And then we started by the class, we name it tic-tac-toe, which is the game class. Just to give you a clear example what will happen later. Later, we are going to instantiate this class and then run the main loop, and that's all. So mainly all the work, it's happening here. All of this, whatever we have here in this class, it's the definitions. When these definitions come to life and start to be executed, when you create the instance from it, and then start the main loop, which is the major function. As we said, on each game, we have a main loop, because main loop, it's making everything continuous and checking if the winning or losing condition is happened. Once it's happened, the main loop, it will be broken. Okay, so now our task is to go and define everything inside of this class. Then it will be, the game will be finished. Now, this is not that much easy step, but we can break it down into small steps so we'll understand it. I'm not going to speak about the constructor right now. I'm going to speak about this function, which we name it initialize the board. Initialize the board, that means it's preparing the board that we are going to play. How to prepare it? We need to draw the lines to split the board or to divide the board into 9 cells. Okay, how many lines I need? I need 2 vertical lines and 2 horizontal lines. According to that, I will have 9 cells in my board. How to do that? 2 loops. The first one is from I to until 2. I, that means it will be from 0 to 2, or from 1 to 2, sorry. What I'm going to do, first, I will create a line depending on the I, and then I'm multiplying by the size of the board divided by 3. Okay, what this should mean? I'm going to the horizontal, or the vertical, which is the height of the board, and then I'm dividing into the size of the board into 3. I will get 200 in my case. Now I'm started drawing the line from the point of 200 and 0, which is the first left point from the screen. Now, just to give you a clear example, I will run it. I will run the game. Okay. Here is the point 0, 0 on my screen. Okay. On my board, not on my screen. My screen here is the 0, 0. But at this point, it's the 0, 0 on my board. And this point, it's 600 by 600. Okay. Now, when I'm saying I want to start from 0 to 100, that means I will start from here. And then I will draw a line until 600, 200. So the start point, to draw the line, you need 2 points, the start point and the end point. The start point is 0 to 100 because size of the board divided by 3, and 0 because it's the starting of the vertical dimension, up to 600, 200. So according to that, this line, it will be drawn. Now, I'm multiplying the value, the 200, by the value of I, which is start by the 1. So I started here. When I, it's become 2, I'll start from here. So this loop, it will help me to draw these 2 lines, the horizontal lines. The second loop is doing the same, but on the second dimension, on the Y dimension. So I will start from 200, 0, up to 200, 600, up to, 200, 600, and 400, 0, up to 400, 600, to draw the vertical lines. According to that, by drawing these lines, I visually divide the board into 9 cells. But this is the first step, and this is what we perform in this loop, in these 2 loops. The first one, which is starting from 200.0, and then the second point, it will be 200 size of the board, which is 600. Now here we can find that 0, it will become the first, and go ahead to the 200, and then size of the board to the 200 also. When I becomes 2, because here I'm multiplying, so it will move from 200 to 400, and by this way, using these 2 loops, I will initialize the board by dividing it visually into 9 cells. But this is not logical division. That means visually I see 9 cells, but there is nothing tell the programming language or tell the engine that we have that if I click, for example, in the middle, it will be the cell, the middle cell, for example. There is nothing yet doing that. It's only visualizing the board. Now, this is the first function that I want to show. The second function is how to draw the O sample, because it's X and O. So the O sample, mainly the logical position, forget about it. It's helped me to determine exactly in which cell I will draw the sample, because it's depending on the click. For example, when I click in the first cell, any place in the first cell, this is a physical or physical position or a grid position. Now I have to convert it into logical position. That means it's something to tell me that this is the first cell, because, for example, once I click here in this any place on this square, the same sample will be drawn. So I want to just to convert the X and O, which is the point of clicking, into logical place. That means it will tell me this is the first cell. Now, how to do that, we will see it. But right now, I'm going to discuss how to draw X sample in general. Okay, that's why here the logical position, I'm not going to think about it right now. The grid position, we have it. It's this self.canvas. Now, what is the canvas? Self, it's our class name. What is the canvas? The canvas is something we prepared here in the initialization, and it's containing the points of the window. So it's representing the board into a term of points. And here where I'm creating it, there is a class called canvas. This class, it's from the library or the package that I import already. It will present to me the window as a canvas, as a cell of points, as a list of points or array of points. So I can decide from which place to which place I'm drawing. So the canvas, it's the interface for to draw samples, letters, whatever you want. Okay. So here in the canvas, I'm using the function called create oval, which is helping me to draw a circle and oval or ellipse in general. And to do that, I will need mainly, as you expect, 2 points, which is from which place to which place, which is how to draw the circle in general. And also I need the thickness of the line, the drawing line. Okay. And also I have to decide what is the color. So the first point, it will be the grid position minus sample size, and grid position minus as the beginning point, grid position plus sample size, grid position plus sample size as the second point. So the first 2 parameters is the first point. The second 2 parameters is the second point. Why I'm doing that? I know that I click, for example, in the first cell, in any way, any place. Now I'm transferring this into a specific place on the cell to help me to draw the O symbol. Okay, so that's why I prepared a grid position points to tell me that from where, if we are drawing the O or the X, from where we should start drawing until where. This will be fixed for any cell. That means if I click in the middle of the cell or on the last point of the cell, at the end, I'm translating using one function. We are going to see it right now. I'm translating this clicking point into a fixed starting and ending point. That's why I will know exactly how to draw. Always, it will be the same drawing method using the same start point and the same end point. Now, the sample size, it's already fixed and we make it in the global functions. So I will start from, let's say, from the center of the cell, and I'm, let's say, shifting it to the sample size, which is, by the way, this is half of the sample size. Okay, to make it, we have, this is the cell, for example. Okay, this is the cell. It's not secret. I'm smoking. Okay, this is the cell. So the grid position, it will be in the middle. When I'm make minus, so I will shift it to here. So the first starting point, it will be here. When I'm add some values, I'm shifting it to here. So I'm drawing the sample from this point to this point. But the grid position, it's in the center itself. It's only in the center. Grid position 0, it's the X value. Grid position 1, it's the Y value. And in general, I'm always translating any point from the cell into the center of the cell itself. So this is how I'm doing it. So I prepare the starting point, the ending point, symbol thickness, it's already prepared in the global function, and the color, it's already in the global function. And by calling this method, I decided how to draw, and by calculating the grid position using this function, which is, we are going to discuss it later, I determine exactly in which cell I'm going to draw my sample. Similar to that, we're drawing the X, but to draw the X, we are make it as 2 lines. Okay. The canvas has basic function for the basic shapes. For example, the line, the circle or oval, the square. But the example, it's 2 lines, one and the other one. So at the end, my only task to calculate the coordinators for both starting point and ending point for each line, and then drawing like this. The same step it's needed to determine the grid position, which is the center of the cell that we click on. So mainly we need starting point and ending point. And by the way, you can see the only difference it's by this, because the slope of the two lines are different. So when I'm in the center for the first line and I make, for example, minus to go to the start point, and the second line, for the second line, I have to make minus for the x's, but I have to make plus for the y's because the slope is different. So the only difference that you can see, it's here. Here it's similar to what we have in the oval, but here we are adding a plus just to decide where is the start point and where is the end point. And we draw the x. So this to function is to draw, but when to draw? This is the most where to draw, in which cell, and when to draw. Just think about it first. Let me go quickly to the constructor. Back again to the previous session, we say that the constructor is we name it the birth method, okay? It's a function inside the class, and this function is called automatically when we ask to create instance from this class. Create instance, that means we are creating object from the class. So in the first call of the class, we are going first to prepare our window. By the way, TK, it's, if you remember, we use this this package, and inside this package we have the TK class, which is help us to create a window as a Windows application. We give it a title, which is tic-tac-toe. This, whatever we are writing here inside this function, it will appear as a title of our window. So here we can, for example, name it as time zones example, and it will appear as a time zones example. We are initializing our canvas, which is a window with the size of the window, the width is 600 and the height is 600. Okay, and then this pack, it's just to make it appear. Binding, it's just to get the click. And here we are going to speak about the events later. But in this window, we are preparing that the whole window, it will be just like a button. And any button in the window, it has a click event. Now, but the button is a component. Now let us back again to the object-oriented structure. We said that we are creating classes, we are able to add object inside of these classes, and also we are able to make instance of these classes, which is the new object. So at the end, we have objects, and inside this object, we have sub-objects or other objects inside it, which is smaller objects as a component of that object. For example, the window is an object, and any button or any list or any drop-down menu inside of this window, it's another object, but it's, let's say, belong to the window. One of these components that it's familiar, we are familiar with it, which is the button that we are clicking it. For example, the next button, that in any window, we can find some buttons. Here, just because we are able to click anywhere in the window, so we are asking that the full window, it will be a button. And this button has a click event. What is the event? The event, it's something appeared in my program. It's automatically detected by the system using the Windows or the operating system libraries, not only Windows, any kind of operating system. And according to that, we are able to catch this event and do something according to that. So when we click a button, there is something in the Windows, tell our program that you click this button. Why you click this button? So we have events appear, and we are able to build kind of function or any process inside of this event to tell that when we click the button, we need to perform 1, 2, 3. Okay. Now, there is a, let's say, mentality of programming. We call it event-driven. That means just only I need to catch the events and do something related to the events. So the people from this let's say, school, they don't want to create very complicated object. They would keep it as a simple object and then managing everything by events. And most probably this has happened in the games, because in the games we have a lot of events to listen to. The click on the mountain, we have some events that we are not doing it. For example, if we have two objects and there is a chance to collision, so this is also another event. So in general, any object we create in the window, it has some events. The most important event, it's a click. And by the way, what we are going to do when we define the procedure inside the click, we will especially determine what we are going to do when we click on the button or on the screen. And then I'm doing some other preparation variable. Just for example, the board status in the beginning, it has to be zeros. The zeros that mean there is no this array telling me that there is nothing drawn yet. There is no O, no X's. Okay, so I don't know what's still zero. It's still empty. The X turn, the player X turn, to tell me that if he has a turn or it's his turn or not. So I will choose exactly which kind. Sorry, what is the symbol I'm going to draw when I'm click right now? So we have X turn, we have X start to determine if the X will start or the O will start. We have reset the board. Reset board, it's start by false, game or it's not over, tie, win, whatever. All of this is, we name it flags. What's the mean of flags? It's a Boolean values. It's always true or false. Just by catching the value of the flags, I'm able to determine the behavior of my program. So I need these flags. I need to know if for each and every click, if there's someone wins, for example. So I'm preparing the flag for the X win or the O win. Once someone wins, that means the game is over. So I need to know if the game is over or not. And what's the value for the tie? That means it's nobody win. All of this is flags. I'm preparing it. Also, I'm preparing the X score and O score, because the game, it can be repeated. So each time X is winning, I'm adding the score of X by 1. And when O is winning, I'm adding by 1. So after, for example, 10 games, we will know that X is winning 6 games and O 4, or vice versa. So this is what I'm doing in the constructor. But we can understand that the most important part right now is to know exactly what we have to do when we click on the screen. Let's think about it, okay? Anybody can suggest what we have to do when we click on the screen. Not as, I'm not asking to write a code. I'm asking as a logical thinking. I'm going to click on the screen. Right now I'm running the game, okay? And then I will click, for example, here. I know as a player, I'm clicking here and I'm expecting to have X or O drawn on the center of the board. But this is as a player. As a programmer, what I have to do to draw the X or O in the correct place. I already prepared the draw X and the draw O methods. It's ready. Okay, and right now we are initializing the board. When I click, what I have to do? Who's able to tell me? No one. I will, okay. I will ask person, and I will just make it Aziz. Hello.
I really don't get it. I'm sorry.
Sorry?
I mean, I don't get the question right.
Okay. We said that the click is event, okay? And from our understanding right now, this board or this window, all of it, it's a button. And when I click anywhere, there is event triggered, which is clicking the button. And according to that, I have to do something when I'm click as a programmer. I have to write something to draw X or O in the suitable place. What is the first important task for us to do on the click? What is the first thing we have to get? What is the value we have to get? I will answer. The value is to get where we are clicking exactly. The X and Y value of our clicking point. And thank God, this is provided to us by the event argument itself, by the event parameters. Okay. So when I'm clicking here, immediately, or even here, by the way, here, okay, immediately it will tell me you are clicking at the X point, for example, 399, Y point 199, for example. So this is the first value that I'm needing. Here, I'm going right now to show to you the click event. Here, the code here from this point up to this point, it's what the program is running for each mouse click, what it's doing, the program, okay? First of all, in the event, we have X and Y, which is telling me exactly where is the grid position. That means in which X and Y I click. Remember, the upper corner of the window, it's 0, 0. The upper left corner. The lower right corner, it's 600 by 600 in my scenario. When I'm clicking, it will tell me, for example, you are clicking on the X200 and the Y200. That means I'm clicking at the first cell right corner, lower right corner, for example. Where these values, it's in the event. By the way, this is event. That means it's function, but it's defined like this. So event argument, it's always there because it's part of the event. And according to that, I have the X and Y values inside it. So the grid position, it's clear for me right now. I know exactly at which point I'm clicking. Okay. Then I have to determine at which cell, in which cell from the 9 cells that I have, in which cells I clicked. For example, logically, we know exactly that the first cell starts from 0, 0 and finished by 200, 200. Okay. So if I'm clicking at the X190 and the Y190, it will be the first cell. But if the X was 210 and the Y190, I will be on the second cell vertically because it's exceeded the 200. According to that, we prepare this function. I'm not going to show it to you, but this function task is to get the X and Y, the real X and Y of the clicking. And according to that, it will determine the logical position. That means it will determine at which cell we are clicking. Okay, so here we are getting the X and Y, and we will return a cell. That means we are clicking in the first cell, second cell, third cell, etc., up to 9. Okay. Now, according to that, for this 2 line of codes, and this is function, you can find it inside the class itself. Okay. For this 2 line of codes, I'm just determine which cell I click in. Now, first, I have to be sure that I'm not clicking a reset board, because when I'm resetting, when the game is over, there is a button called play again. When we play again, I have to reset board. And to reset the board, I'm making this flag, which is named reset board, I make it as true. But right now, the value of it is false. So I'm just to be sure that I'm not in the reset mode. So I'm checking that it's not reset board. Nothing here, just to tell me that we are not at the end of the game. Everything is only a normal turn. Okay, now, also I'm checking if it's the player X turn. Why? Because if it's the player X turn, I have to draw X. If not player X turn, I will draw Y. Oh, sorry, I'll draw O. Because we have only 2 players. So we have a flag for the player X, and this flag, it's controlling if I'm going to draw the X or I will draw the O. So if it's player X turn, I will draw X, which is using this function. If not, which is the else here, if else, See, it's depending on the white spaces. So these two comments are related to each other because they are on the same vertical level. If it's extern, I'm going to run this set of functions, the set of instructions. Else, I will perform this set of instructions. That means it will be the O, to draw the O. Now, this is the second condition. First, I'm not on the end of the game mode. That means I'm not reset the board. Reset the board, that means erase everything. Okay, keep it as only lines, only the cells. Second, I'm checking if it's the extern. For example, it's extern, let's say. The next step, I have to be sure that this cell that I choose, the player is not doubly clicking. For example, it's already occupied by the X player, okay? And he is just only clicking once again over it. If he did that, that means nothing will be changed. We'll stop. No, we'll ask, even we are not going to ask him to do anything. He has to click on another cell, which is, it has to be free cell. So I'm checking if it is grid occupied, okay, which is I'm passing the cell, and this function, it's all we can find it up there, which is this one, okay, to check if the cell it's already occupied by any sample or not. So in case it's not occupied, that means I'm clicking on the free cell. Simply, I have to draw the X using the draw function that we show already, and then updating the board status to know exactly which places having X's and Y's and what's happened for them. And then I'm just let's say reflecting the turn. If the extern here, extern was true, I'll make it as false. According to that, the next click, we will run this set of instructions. And so one click here, and again until the game is over. Now, after this, in the click, and before going outside of the click, we have to check the following. For each click, we have to check if the game is over, if we have a 3 in line. So we are going to check the game over function. It's also a function. We have it here, checking the chat. Please don't feel overwhelmed by this game. We have broken the games down into manageable chunks. Okay, thank you, Hugo, for this. Okay, if the game is over, that means we have 3 inlines or all the cells are occupied. Okay, we will show the game over window, which is a message that the game is over. Otherwise, the game is not over. We are continue to play. Okay, now this is what happened when we are click. All of this, it's when we are clicking on any part of the cell. But we have a set of functions we didn't discuss about them. First is game over. Okay, this is the function is game over. It's checking if we have a winner. Okay, so we have inside it, we create another function, another method called isWinner. And isWinner is checking if we have a 3 X's according to the sample here. If we have 3 X's or if we have 3 O's in line. Okay, so if we found a winner, the game over is game over will return true. Otherwise, it will return false, simply like that. Okay, so this is game over function. Now, isWinner function is just checking the board status, which is array 9 by 9. It's checking the 3 by 3, sorry, 9 values. It's checking the board status to see if we have 3 O's or 3 X's in line. So now what to do? We have the player parameter. We are passing X or O, sorry. Okay, and according to that, we will check the situation for 3 on low, for 3 in row. for the X or the O, according to the parameter that we are passing. It's simple like that, nothing complicated about it. It's only we are checking if we have 3 on row. But how are we checking that? To have a 3 on row, that mean either 3 and next to each other or above each other. That mean for that cells, either all of them have the same X value or the same X coordination, or all of them have the same Y. So that's why here you can see that we are changing the I according to the loop, but always the O is, the Y is 0. So here we are checking for, sorry, the changing the I, but the O is 0, 1, 2. Okay, so we are checking the same for the same I. How it will work? I is 1. Okay, this is the board that I have. I is 1. I'm checking if 0 and 1 and 2 they have the same, and then no, they don't have the same. I will back to the I is 2, and then I will check for 0, 1, 2 for the same row, and go on. Now the next loop, it will be for the vertical, for the Y. So I, it will be here, and then 0, 1, 2. I'm checking it like this. So here I fix the situation for the vertical and horizontal, but still I'm able to win if I have 3 diagonal parameters. So again, I have to check this, which is we are performing here. Okay, what is the value? The values is 0, 0, 1, 1, 2, 2, or 0, 2, 1, 1, 2, 0. Just think about it. What is the index of these arrays to know exactly what's the values? So this is the is winner. Grid occupied also, it's having the memory that which grid are already used during the game. And then we have a grid to logical position and grid to logical to grid position. These two are used for the following. Grid to logical, I will check the X and Y value and get the cell number that you are using, the cell, the first cell or the second cell, whatever. Now, this is grid to logical. Now, logical to grid, I will get the logical position and get the center of that logical position. For example, I'm passing that, okay, I want the grid position for the first cell. So it will return to me the cardinals of the center of first cell. Okay, this is how I'm using it. Okay, in general, this is everything about the game. But we have to run the main loop. The main loop is keeping everything running and listening to each click. So here I'm clicking until one of the flags it's raised. Either X is winner or Y is winner, or the game is tie and there is no more free places. All of this is inside one class, which is the tic-tac-toe. My task right now, it's simply to create instance from tic-tac-toe, which is the object that I have, and run the main loop, which is the method inside it. And according to that, this is what will happen. I will go and start playing the game. I will play one game to tell you exactly for each step what's happening. I start by this click. Here, the flag X player turn, it was true. Okay, the is occupied, it's returning false for me. So this cell was empty. According to that, it was able to draw a X here. And before going out of the event, the click event, it's checking, is the game is over? No, it's not over. If it's tie, no, do we have a winner? No. So right now it's ready to continue playing. But what's happened right now, the X turn flag, it's becoming false. So when I'm clicking once again, it will be drawn as O. If I click here, nothing will happen because this one is occupied. Remember the conditions that I was explaining. Now O, again, the same. We don't, the cell is not occupied. We translate the first step, we translate the X and O, the click place, the click position into a logical position, which is this is the cell 1. Cell 1 is occupied? No. Okay, now let me draw which turn it was the O. So let me draw the O. And again, check, is the game over? Do we have a winner? Or it's a tie or whatever. For each click, it's the same happening until we have a winner or everything is finished. So once all the position is occupied, the game is tied. And here I'm able to click again, click to play again. What will happen? Reset the board. Remember the flag called reset the board. It will become true, and we will erase all the samples, and again to the 0, 0 in the occupation matrix. So again, we have a new games, and we can start again. But in this game, in this time, it's keeping the original turn. The last sample I draw in the first game, it was X. So here again, we continue with O because it's keeping the turn. So the start turn, it was O, and go on, something like this. So we have here, it's a tie. I'm printing it when it's finished. Again, I will let someone win this time. Okay, so we have O wins, and we can see that the player O score is 1, player X score is 0, and we have 1 tie, and so on. This is how we are able to create a simple, easy, and somehow object-oriented game using Python. Again, the code, I was talking to Hugo previously before we start the session, that all the code is ready with me. I'm able to move it to you whenever he is ready with the GitHub repo. I will show you something, but I don't think we are able to go through it. We have to open the for question. But this is the second game that I was planning to show you. It's like this. Okay, so it's more complicated. It's 2D game, and it has also one of the most important game concept, which is dealing with the music and the drawings. For example, all of these are pictures moving, and also acting with the collision possibility. That means we have two objects are striking to each other. So this one, I think, Hugo, you can choose the best scenario. I don't think next Saturday I will be available. Either if you want, I can go and record a video about explaining this game, or make it on not next Saturday, that means after 15 days. Any question, please? Hello.
Hello, can you hear me?
By the way, Aziz, your voice is not 100% clear. That's why I find a problem in listening. So please check the mic, please.
Oh.
Yep.
Let me quickly just transfer to my phone. I think it's my laptop that I have issue.
Mm-hmm. If you want, you can write to the chat and I can answer you.
Yeah, I just want to ask about the last week's game.
Okay.
Yeah. Okay.
Okay. Should I share the screen again? Okay.
Do you hear me now?
Yep. Perfect. Much better.
So the issue is last week game. While I was playing it, I discovered that when I got to the guess right, so it printed error, and the system told me that variable name is not defined. Then I do some like I went through it and I noticed that the variable name was I don't know, it was a local variable anyway. So then I tried changing it to a global variable, and I saw that it's actually it went through. So I want to call your attention to that. Perhaps we forget about that.
Okay. Okay, no issue. Thank you. Thank you very much. By the way, I noticed that. I noticed that problem. And I didn't fix it for one reason only, because I don't think that you will win, by the way. It's not easy to find a number with 6 trails in between 200
I
numbers.
decided to print the correct number so that I can see what happens if I win. So that's how I got it.
Okay, perfect. Perfect. Okay, yes, but by the way, it's small issue, but it's very important to notice that, because it's telling us what is the difference between the local variable and the global variable. It's the accessibility is the most important thing. Local variable is not accessible from all the code pieces. For example, when you declare a variable inside one method, you have to be sure it's not locally declared for that method. If it's needed outside, you have to declare it globally. Yes, thank you, Aziz. Any other question? You go.
Well, it's just about today's one. I see it's somehow complex to me, but because Hugo already said we should not be overwhelmed that it will get used to it.
Yes, you have to break it down into some ideas. First, as I told you, there is the initializing. We have to know how to draw the X, how to draw the Y, how to initialize the board. So this is simple. This is standalone. It's always running, and we know that we are ready. Once we are finished from draw X and draw O methods, we will call them when it's needed. Okay, we know that it's ready. Now, it's the most important part is to know the logic. For example, one of the method of writing code, it will be writing the high-level logic. For example, I know that each time the action happened when I'm click. Okay, so I will decide on a click what I need. Okay, I will know that I have to know exactly which grid cell it's needed. So okay, this is the first step. Second step, to know if it's occupied. I'm going to if I'm drawing X or Y, and then how to draw the X, then how to draw not Y, sorry, O, how to draw the O, and then check if the game is over and all other things. Now I have the high level understanding of my project. It's especially on the click, because the click, it's the repeated event. It's the most important event for me. So once I have it, I will know exactly what is the other function needed, because, for example, okay, how to understand to determine what is the logical cell, what is the cell logical position, which is the cell, which cell I'm clicking in. Okay, I need function to do that. Okay, I define it. I didn't write the code for it, but I define it. I know that this function, it's needed. Then, okay, I need a flag to know if the game is over or not. I need a function to determine who wins, which is the is winner. Okay, so I know right now I have a structure. I have all the functions, but I don't know how to perform each one. So I will break it down. I will go for the first one and decide how to find it. Most of these problems, it will be mathematical problems. You can see you have to know the X and Y, and you know in which range it's located, and according to that you will decide the cell. So this is the way that always you have to start from the real action. Where is your real action? In our game, it was the click. Okay, so we'll start from the click and then break it down into smaller problems. The bunny game, which is the next one, it has two kind of problems. First, we have to create the environment. That means we have a read action that's creating problem, which is showing the rats. Okay, and then this is something automatic for automatic generation. And then we have the player action, which is clicking again to shoot these rats. Okay, according to that, we have to check what will happen on the click. So mainly, the most important step for us, beside knowing the, let's say, the basics, which is how to draw the line, how to deal with the window, and you understand what is the event. Okay, beside that, it's to determine the logic of the main action that we have. The main action in our game, it was the click. So once we understand what's needed for the click, then we will go step by step and do what's needed. Just like assembly, the click here, it's the assembly line. We have everything inside the click, but then we are going, for example, to consider it just like, okay, we know how to make coffee, but at the end there is someone is preparing the coffee beans for us, and there is another one who's bringing the water for us, and something like this. So all of this is sub-functions. We are back again and fill it. But first determine the main logic, the main action that you need. In this way, it will be very simple for you. And inside, during your work, when you need another function, okay, go and define it, no problem. Even if you, for a small game, you finish with 100 function, and then you decide that, okay, I create this function, but at the end it wasn't needed. Okay, remove it. The most important, determine the main logic. Now, one last point you have to notice. When you finish everything and you run the game, most probably it will not work. Not only game, any project. Why? Because the major logic or the major action, it's not wrong. It's perfect from your side, because you just have to think step by step what I need to do. But simply because we as a human, we used to ignore the small problems that might appear. For example, maybe there is one condition you didn't control it in a best way. So you can find at one point this a global or local variable, for example. There is a condition that it's always triggered, so you have to change it. So when you debug, you will start understand exactly what's happening and how to fix it. Just I will show this part, which is how to debug. In Visual Studio, simply, this is the first instruction that's running. So when I click on the right panel here, or the right tray, it will be as red. And when it's the turn of this instruction to run, it will become blue. Here I have two options, F11 or this button to step into this function, or step over. What is the meaning of step over? Step over, that it means run what is inside the function and continue to the next. Step into, no, go inside the function and show me what's happening. For example, I will step into the main loop and I will see this is what's happening for the main. If I step into this, I will find that, okay, it's continue to draw some, the window, which is this one. And then when I click, it's continue with the step into. So I know exactly what's happening on the click. I can go right now, step by step. I step into the logical function, the logical to grid position, and so on. So this is how I'm able to determine where is the breakpoint. This red point, we name it breakpoint. That means where you stop the execution of the program to check and debug step by step what's happening. By the way, when you just mouse over any variable, you can find the values of this variable at that point. So it will show you a clear understanding about what's happening. So if there's any error, you can fix it. This is in general how we debug. I hope this was clear.
Yes, thank you very much.
Any other question, please? If not, I will celebrate with the early run out, okay? I'll run away.
Thank you very much. Hugo, can I ask you a question, Hugo? It's about tomorrow's class, the one you normally do on Sunday. Are we supposed to be online for it also? Because when I go through the recording for last week, it's as if you were addressing some audience that were in front of you. So I don't know, maybe you decided to use that style, or maybe there are some of us that are attending. So I wanted to confirm that.
Hugo is not here, I think.
All right, it's fine. Thank you very much.
Thank you. So I think if there is no other question, I think we are done right now. Again, the code, it will be, who's calling me from Burundi? Okay, this is strange. Okay, you go. Okay, it's still muted. The mic is not working. Oh, okay, there's something a bit. Okay, Hugo, the code will be available anytime. Just I will send it to you, and I will prepare another. You can decide if we have to postpone it for 15 days for the bunny game, which is the last game that we have, or you want me to make a separated video and you can push it to the YouTube. It will be okay, but because it will take time, it will not be 20 minutes. Will not be enough for it. Okay, so. Yes, you have a problem in your audio. Yes, it's clear that you are not muted, but we are unable to listen to you. Okay. Thank you for joining, and thank you. I hope it was clear. I hope it was helpful. If there's any question, please you can receive it from the guys. You can forward to me. I'm also available on the Slack channel, but maybe it will be 1 day delay on the response. And forgive me, I have to go. Thank you.